Tonight, we are going to spend a quiet stretch of time with a very old building material. Not a king. Not a battle. Not a dramatic speech. Just stone, ash, lime, seawater, and patience. If you have ever seen photographs of Roman ruins, you may have noticed something unusual. Columns have broken. Marble has fallen. But some harbor walls, foundations, and domes still stand after nearly 2,000 years. Our story begins near Naples, in a place called Pozzuoli. That region produced a fine volcanic ash. When mixed with lime and water, this ash created a paste that hardened very well. The ash became so important that its name spread, Pozzolana. Roman builders did not invent every part of this process. Other Mediterranean cultures used lime mortars too. But Roman engineers systematized the method and used it at enormous scale. Roads, baths, aqueducts, warehouses, ports, temples, apartments, and domes. Imagine a Roman construction site. Dusty, loud, practical. No electric tools. No concrete trucks. Laborers carrying baskets. Masons shaping stone. Foremen measuring walls with cords. The recipe was simple in principle. Limestone was heated in kilns to produce quicklime. The lime was mixed carefully with water and volcanic material. Depending on the project, builders added rubble, broken brick, or stone fragments. For major walls, they often built outer faces in brick or stone, then filled the inner core with concrete. This reduced carving labor and allowed curved forms. And curves were central to Roman architecture. Arches, vaults, and domes redirect force downward. Concrete could be shaped into those forms more easily than cut stone alone. The result was wider interiors and strong, elegant ceilings. The most famous example is the Pantheon. Completed in the 2nd century, during Hadrian's era, it still has the largest unreinforced concrete dome in the world. Inside is a circular room and a dome like a sky. At the top, the oculus lets sunlight move slowly across the interior. The dome works through careful material choices. Heavier aggregate lower down. Lighter aggregate higher up. And less thickness toward the top. It is not mystery. It is patient engineering. Roman concrete also helped daily life and imperial logistics. Armies needed roads and bridges. Cities needed baths and water systems. Ports needed breakwaters to reduce wave force. Concrete enabled faster, repeatable construction across distance. In marine environments, the story gets even more interesting. Some modern concrete can degrade in seawater over time. But parts of Roman marine concrete sometimes strengthened with age. A likely reason is long-term mineral formation. With volcanic ash, lime, and seawater, new minerals formed inside pores and cracks over years and centuries. Some studies point to durable crystalline phases that improved cohesion. In certain structures, time became an ally. Of course, not all Roman structures survived. Many collapsed from earthquakes, neglect, or material theft. But enough endured to raise a modern question. What can we still learn from this? Modern Portland cement is fast and standardized. It made global construction possible at scale. But cement production has high carbon cost. So engineers are revisiting ancient and low-carbon blends, including volcanic materials, for selected applications. History becomes practical here. Ancient techniques can become modern prototypes. Not copied blindly, but adapted with testing and measurement. There is also a lesson about speed. We often optimize for immediate results. Roman materials, intentionally or not, were allowed to mature over long timelines. They evolved quietly while doing their job. Imagine a harbor wall across many winters. Wave after wave. Salt spray. Calm summers. Ships arriving and leaving. Inside that wall, tiny chemical processes continue without noise. In sleep history, loud events fade first. What remains are routines. Mixing lime. Carrying ash. Packing layers. Repairing cracks. Ordinary labor, repeated until it becomes civilization. If you walk through a Roman port at dusk, you might hear ropes, gulls, and footsteps. You would not hear the words material science. But that is what it was. Experiments repeated across generations. Methods refined. Failures remembered. The empire changed and fractured. Trade routes shifted. Knowledge scattered. Centuries later, researchers returned to old walls with modern instruments. Ancient structures became laboratories. Roman builders worked for immediate needs. Hold a dome, protect a harbor, supply a city. They were not trying to impress distant scientists. Yet their practical choices created long-lived data for the future. Before we close, picture one worker at dawn. Hands rough from lime. A wooden form ready to be filled. No promise that this wall will matter in 2,000 years. Only the next layer. Then the next. Some of the strongest human creations are not the loudest ones. They are built carefully, with good ingredients, and enough time for hidden processes to work. Thank you for listening. Rest well. And let your thoughts settle like fine volcanic ash in still water. Good night.